Well, Bob just broke the record. Haha. Bob is the new oldest human in the world. Now, we have 3 humans. There's really only 1 human class, but there are 3 human objects. And these objects are referenced by 3 variables named Mike, Alice, and Bob. And each human has its own set of variables. Let me draw this for you. Let's give humans names too. All humans need names. Mike, Alice, Bob. Let's see, Mike was 42, and we'll say this one is Alice, who was also 42 but was false. And Bob had a, what was he, 116 and had a true. Why can't I see that? There we go. And I'm going to draw a little arrow off to that. This was Alice, right? That's Bob. I'll draw a little circle here to designate that variable. Okay. These things that I am drawing over here are objects of class human. Now, a human has an age and a sex and a name. In fact, I did that out of order, because over here I did name, age, and then sex. Okay. There can only be one of every class. With me? There can be many of every object. Every object must have a class. So if this were car, this could be your Toyota, and this could be somebody else's Toyota, and that could be somebody's Ford. There's no class that you can't make lots of objects of, but you know, it's an is-a representation, and I think everybody kind of gets that concept, right? Okay. So now if we return to this code here, now we've kind of got the concept. Let's see if we can stick the ball actually into the code and make it work using ball as a separate class, and I'll show you how that simplifies things. Okay. So we've got main here. I no longer need this ball. I'm just going to say ball b equals new ball. And I'm going to get rid of all those variables. The word new is a very special word in Java. This means create a new object. You always pass to it a class name, and given that class name, it's going to instantiate an object. That's a little piece of memory that's just big enough to hold all the variables for that class. So ball is going to have 4 variables: x and y position, vertical and horizontal velocity. Okay. About time? Okay, sounds good. I'll wrap it up. Now, a bunch of times we're going to do it. We're going to draw some blank lines. We're going to draw the grid. And right here, I have an x and a y. But you see how there's no longer an x and a y in my program, is there? But I do have something called b. b is my ball. In fact, that's being sloppy. I'm going to write it out with ball. How do you tell the difference between ball and ball? This one has a capital letter, therefore it's the class. This one has a lowercase letter, therefore it's a variable. Variables refer to objects. In this case, there is one object of type ball, and it has those 4 values in it. I'm going to say ball.y, nothing to do with Bollywood, and ball.x, that wasn't even funny. What do you suppose the dot operator does? If we come back and look at this picture, I'm suggesting that every object has variables in it. Okay, well, look at this. What is age? You can't answer that question because are you talking about Alice's age or Bob's age or Mike's age, right? Age is not just one variable. Age is a variable for every single object. Likewise, over here, I'm making a ball. When I say X or Y, there's no such thing as X or Y anymore because I might have made 50 of those balls. I have to tell it which one. I'm going to tell it ball because that's the one I'm doing. Ball dot X and ball dot Y. The dot operator basically goes out here and it looks inside the square that you referenced and it gets the value out of it. Does that make any sense at all? Okay. I can tell I'm a little bit blowing your minds. How about we just store in your minds that this is a concept and we're going to be repeating this over the next couple of days until it makes sense because this is one of those core principles that really does need to sink in. Okay? Somewhere I've got a variable.
Can you maybe fix it so that the object in this example only has 2 things instead of 3 things?
Yes.
So with the X and the Y?
In fact, instead of using so many different analogies, let's stick with just one. Here's my class. My class is going to have in it int x, int y, int vx, int vy. And this is the class ball. This is going to be my object. There's a variable over here. Gotta get my names right. Now my variable refers to, meaning it tells the memory location of that object. And inside of this object, it's going to have x is 9, y is 20, or wait, x is 20, y is 9, vx is 1, and vy is 1. So this is what's called an object. And when I say ball.x, what's going to happen is it's going to start with ball, and the dot is going to follow the arrow to the object. And once it reaches the object, it's going to find the slot that represents x, and it's going to give me a 20. And when I say ball.y, it's going to follow the arrow to the ball object and give me the y slot, which is this, and it has a 9 in it. So here's how that happened. I have right here a constructor which specified all of those initial values. Right here, when I said ball equals new ball, wow, that is a confusing line. Ball equals new ball. I made a new variable that can refer to ball objects. I initialized this variable with a new ball. Right here, when I make a new ball, this calls the constructor. So at this moment, a ball was created somewhere in memory, and it called into this method right here and set its x to 20 and its y to 9 and its vx to 1 and its vy to 1. Okay? One of the cool things about this is if I wanted to adjust my game like this, I could do it. Now I would have 2 bouncy balls. And if I wanted to do it again, I could make as many bouncy balls as I wanted, all bouncing all around, and with no extra code, the program would just adapt to it because I would have, well, that's mostly true. I would have each of those objects taking care of everything that a ball does and everything that a ball has. Okay, so right here, when I say ball.x and ball.y, I'm referring to the x in the ball, as opposed to just the x, because there's no longer just an x. There's a ball's x and a ball's y. And all I have to do down here is say ball.move, and I'll pass to it my width and height. And now the ball will move. And if I did it all correctly and made no mistakes, which would be amazing, no coder should ever write that much code without testing it, then it'll just work. Okay. It just works still. And if we look at it, I don't know if I've simplified it that much, but it's a bit simpler. All that move code is gone, all of the x and y is gone, and the vertical velocity and horizontal velocity is gone. And by gone, I mean it's moved up to here. Now you might say, hey, that was just extra work, but in fact, it's so much more organized now. And if you were to start writing this program and turning it into something bigger, you'd find that organizing into classes and objects really simplifies things a great deal. Does that make sense to you? Okay. We've covered the basic concepts. I definitely need to spend a little more time on classes and objects, and we'll do that next time, because I am a little out of time. But do you have any final questions for me regarding classes or objects, or the dot operator, or the new command, or constructors? Those are the main things I want you to see if you can kind of absorb. Yes?
I'm getting ahead of things. What's the difference between a public class and a private?
You'll see the word public. You'll also see the word private and protected. And those pop up all around in Java. It's kind of unrelated to the concept of a class. This just means, is this code accessible to only my project or other projects that want to call into my project? Now, the easy solution is just make everything public and then the compiler doesn't yell at you. The good coding practice is make everything private because you want the compiler to yell at you. Why do you want the compiler to yell at you? Because the more it yells at you, the more it finds your bugs for you before they actually affect your program, right? That saves you time. So there's reasons for that. For the most part, I don't even bother specifying because the default just works nicely. Public and private's kind of, it's not really important until your program gets really big. Once your program is big enough, then you start wanting extra rules in place to make sure this code can't access that code, and that helps you keep it clean. So you will see the word modularity a lot. This is kind of the big drumbeat of computer programming. It means put stuff together that goes together and keep things organized and separate. The more modular you write things, the better your code is. And essentially, good coding is all about, can you organize stuff into modular components that have as few entanglements with the rest of the program as possible? The more little self-organized pieces of code you write, the better. Remember earlier I said start building a war chest full of all the pieces that you're going to put together when you need to program? Well, if you write modular code, then you have a bunch of little pieces of code that do stuff that aren't entangled with the rest of your software. And that means you can just toss them into your chest and you can pull them out at will. And somebody says, hey, I need software that does this. You just say, okay, this piece, this piece, stick them together, bam, my code works. And modularity is ultimately the key to everything. The more you can just have pieces to work with. Imagine someone asked you to build a castle, and all you did was 2 towers and a wall. Bam, here's a castle. You see how easy that was? A lot easier than brick by brick by brick. Now, I keep jumping between abstract and real here. I hope you can keep up with me. But modularity is the name of the game in programming, and classes exist for one purpose. They don't allow you to do anything you couldn't do anyway. But the purpose is they do allow you to organize your code into modular components. And that means you can start having reusable pieces that can be fully debugged and can just start working, and you don't have to get the whole thing working. You just organize your pieces and get them working. And that's kind of the big secret power of computer programming. Okay. Well, any other questions are standing between everybody and lunch, so I'm guessing nobody else wants to keep hammering me here. Let's go ahead and eat, and tomorrow we'll talk a little bit more about classes. We'll do another test like usual, and